Good morning or afternoon, everyone. This is day 3 of the algebra extension lesson for slopes. We're going to be dealing with parent functions in today's lesson. So a parent function is the most basic form of any function. So you're going to be in algebra, you focus on linear functions and quadratics. And parent function is without any other necessary additions. It's the most basic form of it. Okay. So for a linear function, um, for linear graph, the the parent function is y equals x, which has been graphed for you over here. Okay. That just means that, your excuse me, it's your y-intercept is 0 because it's going through the origin, and your slope is 1 over 1. It just goes up 1 to the right 1. So it's just basic. It's splitting the graph, the coordinate plane in half. If you fold it through that, it's just perfect. Okay, it's symmetrical. So this is a parent function. On the same grid, show their graph in different colors. All right, so I'm going to be doing this in different colors. You have y equals 2x and y equals 1/2 x. In the last lesson, we went over graphing using slope-intercept form. So this one over here, y equals 2x. So you would, because there's no y-intercept, you would just do plus 0 for the y-intercept. And the slope is going to be 2 over 1. So remember, when you're graphing this, you plot the y-intercept first, which is 0. So that's going to be your first point. All right, and now you're going to do 2 over 1. It's going to go up 2 and to the right 1. They're both positive, okay? So you're going to keep doing this. Whoops. You're going to keep doing this. You're going to go up to 1, 2, into the right 1. Go up to 1, 2, to the right 1. Go up 1, 2, to the right 1. And you can keep doing these steps. One thing you can do is, if you're trying to get the other part of the graph in the non-positive, the negative part of it, you do the complete opposite of what's there. Meaning that right now you're doing positive 2 over 1. To get the other end of it, you just change the signs. So you're going to be going down 2 and now to the left 1. So go down 2, 1, 2, and to the left 1. Down 2, to the left 1. Down 2, to the left 1, and just keep going if you want more points. And this really does help. Sometimes when your your graph doesn't have enough room, it actually helps to have that extra space to go the opposite way. Okay, and now I'm just going to draw a line through those points. And I did a pretty good job the first time. Kind of impressed. Doesn't always happen on my book. And now let's do the other graph in blue, okay? In blue. So y equals 1/2 x, and remember it's plus 0. And you're going to go up 1 and to the right 2 this time. So your first point is at 0 at the origin again, because it's your y-intercept. You're going to go up 1 to the right 2. 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 And that's as far as we can go. And to get the other side of it, just change the signs. -1, -2. So you're going to go down 1 and to the left 2. So down 1 to the left 2. Down 1 to the left 2. Down 1 to the left 2. And so on. And now let's graph this with my line tool. I can draw pretty straight lines on paper, but with the drawing pad, it's not necessarily the same effect. And there you go. Those are your two graphs. I'm going to be writing in a different color. Let's do purple so we can. All right, so how does the two change your graphs? Look, you're comparing it to the parent function. So how does the red line, how is it different from the dashed line, the parent function? If you're looking at it, the red line is making the line steeper, meaning that if you were going on a ski slope, which would be the steeper line, okay, which would be the steeper slope. So the 2, whoops, okay, where is my, can't find me, okay. The 2 is making the graph steeper. Okay. And now if we're looking at how does a 1/2 change your graph? So comparing it to the parent function again, 1/2 is making the graph less steep or flatter. So the 1/2 is making the graph less steep or quote unquote flatter. Okay. So that's one way of looking at it, okay? And we'll discuss this more. So what is a role of m in y equals mx plus b? The role of m is just measuring the slope is the steepness of the graph. So it measures, it tells you the steepness of the graph. Okay. Y equals x's graph for you. This is a parent function on the same grid. Graph y equals negative x. Okay, so let's go back to, I'm going to do y equals negative x. So this is going to be, again, there's a negative here, so I'm going to rewrite it as y equals negative 1 over 1x. Remember, there's a 1 there, plus 0. So you're going to have, it's going to start off at 0, and now you're going to go down 1 to the right 1. And I always like to keep the negative on top. It just keeps it consistent. Unless you have to go the opposite way. So go down 1 to the right 1. Go down 1 to the right 1, down 1 to the right 1, and you can keep continuing this if you realize it's a trend. Doing it the other end of it, it would be positive 1 over negative 1. So you would be going up 1 to the left 1. So up 1, left 1, up 1, left 1, up 1, left 1. And you can just keep going, but I'm going to stop at this point. And now let's connect the dots to get our line. Oh, that didn't work very well. Sometimes it just takes some trial and error to get there. This is a terrible graph. I even know what this looks like, and I don't know why I'm not starting where it should be. There we go. That's what it's supposed to look like. Okay. Now let's do the next one in blue. All right, in blue. So this is going to be negative 2 over 1 plus 0. So you're going to go down 2, right 2. So before we do that, we have to plot the y-intercept, which is 0. And we're going to go down 2 to the right 1. 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 Do the same thing, whoops, to the other, up. So the other way would be positive 2 over negative 1. So up 2, left 1. So up 2 to the right 1. Oops. Up 2 to the right 1. Left 1. Up 2, left 1. Up 2, left 1. It just keeps doing that. Ugh. Doesn't give me a break. And now the actual line. Again, I'm doing my best with this. That wasn't very good. A little better. That's fine. Let's do the next one in green. All right. So negative 1/2 x plus 0. So you're going to do, again, I'm going to take this negative and put it up top and make the bottom positive. So down 1 to the right 2. I only need one negative when it's a negative slope. Make it just one of them negative. Down 1 to the right 2, 1 to the right 2, down 1 to the right 2, down 1 to the right 2. And then the other way would be up 1 to the left 2. So up 1 to the left 2. And you'll know if it's off because it's supposed to be a straight line. So if your graph is all like wonky, then you know you made a mistake. Just get like the positive to the right of the y-axis correct, and then it'll be like you'll know when it's wrong the other way. And then the line, I'll take it. All right, now the questions. All right, so how does a -1 change your graph? If you look at it, the parent function y equals x is dashed. The -1 is actually like inverting the graph the other way. It's changing it into it's going downwards. The graph is no longer going positive. The graph goes in the negative direction. How does a -2 change your graph? It's negative and has a higher steepness. How does -1/2 change your graph? It's negative and lower steepness. What is the role of m when it's negative? The graph is going to go in a negative direction. The graph is going to be opposite. It's breaking up the symmetry the other way. So the graph is opposite. I don't know. I mean, your wording, what you understand what I'm saying is two completely different things, but it's opposite. One is going the other way, the other, like, you know. Anyway, how much more do I have? Let's see if I can, I don't know if I can do this in 2 minutes, because I have so much time left. I'm gonna stop this video now and then continue the rest of the notes in video number 2. All right, bye.